So the webinar is given by Benoît Hansmans, who will cover NeuVector, and me, Kevin Kiovile, I will talk about the cluster autoscaler for Rancher. So at first, I will talk a little bit about the basic of Rancher, just in case there's people who are not familiar with Rancher. Then we will go directly for the cluster autoscaler for Rancher RKE2. And then Benoit will talk about NeuVector for the security of Kubernetes platform. So we'll do a quick introduction of Rancher and of RKE, RKE2. So basically, Rancher is an application that helps you manage your Kubernetes clusters located anywhere, either on cloud or on-premise. And also, it can help you with the provisioning of Kubernetes clusters. So you can provision clusters using cloud provider Kubernetes solutions, such as EKS, AKS, GKS, and others. And you can also use the SUSE Kubernetes distributions, known as RKE, RKE2, and K3s. So they can be provisioned through Rancher. You can also import your existing Kubernetes clusters into Rancher, so you can manage them directly in Rancher. From Rancher, there is something called also an app catalogs, which simplify the installation of additional components. For example, NeuVector. You can also install some monitoring stack, Longhorns. Everything is installed with Helm. Also, there is something really nice about Rancher. It is the centralized management and authentications of your users. So you can add your own Active Directory, and you can manage the role and permissions of all your users from Rancher for all your Kubernetes clusters. So RKE and RKE2, those are two Kubernetes distributions developed by SUSE. They are used to provision clusters with Rancher. They are completely open source and fully compliant with CNCF. So RKE, the difference between the two is that RKE uses Docker as container runtime. The control plane components are managed by Docker, and they are started as Docker containers. So, for example, the kube API, the kube scheduler, the kube controller. And RKE use as CNI, Canal, Flannel, Calico, or Weave. And there is RKE2, which is a more recent distributions, which use container D as container runtimes. The control plane pods are managed by kubelet. And for the CNI, you can use Cilium, Calico, Canal, or Multius. And one point is that RKE2 is more focused on the security. Historically, it has been developed for the American government and has been known as RKE government. So now, after that introduction of Rancher, we can talk about the cluster autoscaler for Rancher RKE2. So when you deploy your clusters, at first you might not know the initial sizing of the clusters. Also, the usage of the clusters can vary depending on the times. For example, at the beginning, you might not need the full capacity of the clusters, and also at some point of time, you might need some extra capacity for a short period of time to handle all the load. And that's where the cluster autoscalers comes in. So the cluster autoscalers is a tool that will automatically adjust the size of the Kubernetes cluster. So it's really a useful tool that will bring the horizontal scaling into your clusters, and it will help to optimize the resource utilizations. Therefore, it will lower the cost of the clusters because it will free the resources automatically when the workload goes down. So the cluster autoscaler can be used with various cloud providers. So one is Rancher for RKE2 provisioning. And you can also use it for AKS, and probably a lot of other known one. So how does it work? For example, here we have Kubernetes clusters with 3 worker nodes that are full of pods. If we start a new pod, the pod is unschedulable because there is no resources available in the clusters. And the cluster autoscaler will automatically add a new node into the clusters, and then Kubernetes can start the pod into the new node. If there are nodes that are underutilized for an extended period of time, then the cluster will automatically scale down the autoscaler will automatically scale down the clusters. And also it can help optimize resources by scaling down existing node whose pod can be moved. So how does it work? So simply we deploy the cluster autoscaler as a deployment. So we'll start as a pod into the clusters. The cluster autoscaler will check the cluster configurations by calling Rancher, and will watch the API server to look for any unschedulable pods. So if there are pods that are unschedulable, the cluster autoscaler check if the unschedulable pods can fit in any potential node group. So here there is the node group app and the node group iCPU. So it will check for the capacity, the annotation, the date, if there is some restrictions. And if there is one that fits, the cluster autoscaler called the API of Rancher to scale the cluster. So here, for example, it will add a new node into the node group app. And because there's a new node and there is the available resources, Kubernetes will automatically start the pod into that new node. So for the configuration of the cluster autoscaler and how we will deploy it, we will do the following. So we will create a new user for the autoscaler with the minimal authorizations. So you will have a cluster role with some permissions, so get, update, and the clusters resources, and update and the machines resources. And there will be also a project role that will have the get and list permissions and machines resources for in the namespace that contain the cluster resource. So by default, it should be a fleet-default from the local cluster, which is the cluster that where Rancher is installed. After we set up the authorizations, we will set up the clusters annotations. So to specify into the cluster which node group should be scaled up and scaled down. So we'll specify the minimum and maximum size of the node group. And optionally, you can set annotations about the CPU, the memory, and the storage of the node pool if you want to scale up or scale down to 0. Once we have done that, we can begin to deploy some resources into the clusters. So we will deploy a service account and the roles associated. So there will be a cluster role and simple roles. And after that, we can deploy some secrets that will contain the Rancher credential. Optionally, you can also add the certificate authority of Rancher. And we will deploy the clusters to scalar, so it will be a deployment. And here you can uh, specify your own parameters depending of your needs. So that was all for the talk. Now we can go for the demo. So I can show you how it works. Yeah, let me share my screen again. Okay, so here I am in my Rancher interface. So the first step I talked about precedently was to create my user. So here I go to user and I create a new one that will be called autoscaler. I will set the password. And it will have the permission user base, so only the login access. Now that the user is created, I need to create the roles. So I already created them, so we can just check the configurations. So here I have my cluster role, which is called autoscaler. So we have here the get update for clusters and the update for machines. And there is the project role, which has the get and list for the resources.cluster.x-kvtest.io. So now that we have those roles, we need to assign the permission to the user. So first, we can set the project role permissions. So in my local clusters, so Rancher cluster, I go to project namespace, and in the project that contains the namespace fleet defaults. So here it is the project system. I can add my new user with the project role, autoscaler. Now that it's done, I can set the cluster role. So the cluster role will be set into each cluster you want to scale. So here I am in my clusters, and I can add a new user. Oops. With the autoscaler cluster role. So now it's set up. I can configure the annotations. So if I go to my clusters, we can just check the configurations. Here you can see that I have 4 node pool, the CP, so control plane, the worker pool, and then I have a scale up and a scale down node pool. So we'll set the annotation and the scale up and scale down. So to set the annotations, we need to go in the YAML file. So you can do a edit YAML. And here, I will just search for my scale down and scale up node pool and add my annotations. So here in my scale down node pool, I'm saying that I want a minimum size of 0 and a maximum size of 3. And for my scale up node pool, I will specify the same. So I can save now. So now we can check the deployment of the Kubernetes resources. So if I go into my demo autoscaler cluster, I can do an import YAML. And here I will import the service account. So the cluster autoscaler service account that will be used in the deployment. And there is the cluster role. So he has multiple permissions to update, create some resources, and also a role in kube-systems to create and update some config maps for the autoscaler. So I can import those resources so we can see there's the cluster role, the binding, and the service account. Now we can deploy the cluster autoscaler. So for the deployment, I need multiple informations. So I have my secret. For the configurations, I need to specify the Rancher URL. So here it's already set up. I need to give the token of my user. So for that, I will connect with my user and get a new token. In API keys, I can create a new API key. Just for information, with the new update of Rancher, there's automatically the 90 days expirations. So if you want to create a token that doesn't expire, you need to go to the global settings and search for the hot token max TTL dash minutes and use the value 0. So now I can create a token that doesn't expire. If I'm logging, and now I can create my token, so it will never expire. I can add the description autoscaler so I don't forget that it was for the autoscaling. So now that I'm done with that, I can just close it and go back to my deployment. Okay, so I added my token here and specifying the name of the cluster. So it's demo-autoscaler and the namespace. So by default, it's fleet-default. I already set the certificate of Rancher. And then I have my deployment. So it's basic Kubernetes. I specify the version of the autoscaler I want to deploy. So because I'm using a RKE2 1.26, I'm deploying the 1.26 version of the cluster autoscaler. And here you can specify multiple parameters depending of your needs. Here, for example, because we are doing a demo, I'm setting very low time for the scaling and scaling down of the clusters, so it doesn't wait 5 or 10 minutes. So once everything is set up, we can just import. And now, if we check the logs, normally it should scale down directly my clusters, because if I check my nodes, the nodes in the scale down node groups, there is nothing that run on those nodes. So you can see there's no workload. So it will automatically scale down the existing nodes. So here, if we check, I have 3 machines in my scale down node groups, and we can see that there's already some taints I did on those, and there's already one that is being deleted automatically, because I specified precedently that I wanted 0 to 3 machines in that node group. So all the one machine is deleted, and the 2 other one will be deleted soon. So the scaling down is working as expected. So if we want to test the scale up, I can import Nginx to add some load. So here I have my Nginx. I say that I want to deploy on the node which has the following label, so demo-autoscaler scale up. So I only added that label in the node group scale up. And for example, I will just start one replica at first. So we can see that it cannot start because there is no node available. due to my restrictions. And if I go to cluster management, here we can see that there is no more machine in the scale down. And because I started a new Nginx, it will automatically create a new node in the scale up node group. So my new machine is currently being provisioned. And if I go back to my clusters in my Nginx, I will update the number of replica. And for example, I will say I want 4 Nginx. Normally, if I go there, we will see that it will create, here we can see them. It automatically created the 2 other nodes because I added more Nginx. So we can see that it's working perfectly fine, and it's really easy to set up.
So I'm taking the magic wand over, and I will talk about NeuVector, which is a security application that is very useful to secure a Kubernetes cluster. So NeuVector applies to any flavor of Kubernetes cluster. It could be the vanilla Kubernetes, the OpenShift, the Rancher, or the Tanzu. They are working on all type of Kubernetes. It is it fits very well to the DevSecOps technology because it can apply security at various parts of the DevOps loops, and so it can replace some other security component that just does one function. NeuVector has several functions it can do and provide security into this cluster. So let's jump directly to see a little bit more how it is installed, what it is. So it's an application that is containerized. That means that every function is put into a separate pod. And this is all the function that comes with a NeuVector when you install it. It has a manager that is the graphical user interface we are going to use today to have a few example of usage of NeuVector. The scanner, there are 3 of them that are doing some job in parallel to scan the nodes, the containers, and also the image in the registry. The updater is going to search every day for new known vulnerabilities, and when it's updated, is going to deploy the scanner again that will integrate the new vulnerability that have been updated. The controller is going to control all the components of NeuVector. There are 3 of them for the high availability. And then finally, the enforcer is a daemon set that is deployed on each node in your Kubernetes cluster, and is just going to apply all the rules you have defined in your configuration. So let's jump to 2 use cases. We are going to see 2 scenarios today. So NeuVector can do a lot of things. We just focus on the application part when you have some application, some workload that are already deployed into your Kubernetes cluster. And we consider in that case that your cluster has been compromised, and if you don't have a tool like NeuVector, it's very difficult to see that you have been compromised, and you will see that NeuVector can help to identify such action that are considered as attack into your Kubernetes cluster. So the first scenario we are going to look after is the data leaking prevention. You may have heard that a few weeks ago in France, there has been a big operation that where social security numbers have been stolen, and more than 30 million of them have been stolen. So I wanted to show you what could have been possible if that was this type of operation, what NeuVector could have seen to prevent that from happening. So you have your application into your Kubernetes cluster. You have your namespace. You have the pod that is called my app in this case. And the function of this application is to communicate to an external website. It could be the normal behavior of this application, or it could be that the application has been compromised and so is exfiltrating some data to the external website. So if you don't have any application, any tool like NeuVector, there is no way you can see that from the traditional tool from the Kubernetes. You need something that can inspect the data inside the packet and can see that happening in your cluster. So when you deploy NeuVector into the cluster, so you can see all the function we have seen before. If this number, this the French social security number is exfiltrated from the pod to an external website, you will be able to see that, and then you can take some action to prevent it. So let's jump to the demo. I will show you that in action. So I also have installed it on the SUSE, on the Rancher cluster. And so when you deploy it, it's just an operator you deploy in Rancher, and then you can see there is a NeuVector menu appear on the left. When you click on that button, you authenticate, and then you reach the NeuVector graphical user interface. So that's the dashboard. You already see there are a lot of information here because by default, NeuVector is going to assess your system and report all the vulnerabilities you can find in the nodes and the pods. And so let's just start with a few activity we can do. One of the function is the network activity. So that's also a nice feature where you can display all the components of your Kubernetes cluster. For example, external means it's outside of my Kubernetes cluster. My app is the pod I have deployed that has been compromised. And so now we want to apply this DLP, data leakage protection, to be able to catch this kind of exfiltration. So to do that, you have some sensor that are part of the policy. So by default, NeuVector comes with already some sensor. For example, you have some sensor about the credit card is able to detect any type of credit card number if they are exfiltrated. Also the social security number, but that's the American format. So I've created a new one for the French social security number. So you can see it's just a rule. I have a regex rule that just match the format of my French social security number. So I'm going to apply this sensor to my pod and see what will happen. So how do we do that? We have the group. So the group is the list of all the pods and the container inside my cluster. I can use the filter here and search for my app. I see my app here. So from here, I have a lot of different options. I can see, for example, all the processes that are running into this container. I can see if there are some networking connection from that pod. And then what we are going to look at is the DLP. By default, there is no sensor attached to the pod, and I'm just going to add the one I have created. So that's the one for my French social security number. I apply it. And so now my pod is ready to detect such exfiltration. So of course, the data has to be appear in clear into the network. So that's the case. It's HTTP here. So I'm just going to run an example. So just a simulation of data exfiltrated means from the pod, my app, I'm going to send some data that contains my social security number. So if my it's working well, you can see in the security event, I have a new log, a new event that detects that my rules has detected something, and you can see some details about it. You can see what pod is concerned by this event, and also where the destination is. You can also even show the packet. So when the traffic is clear into the network, you can see that there are some clear data, and I see a number over here. I could even download that packet and use Wireshark to get that packet and do some further analysis. So that's very very powerful. And now we can see also on the network activity. So it's going to draw a link from my app pod to the external object here. And if I click on that link, so it's a HTTP, that's why the traffic is in clear. You can see I see that alarm as well. And I see it's triggered the sensor about the social security number. So from here, I could protect that from happening if I want to stop that, because that's an abnormal traffic. So to do that, I go back to my policies. I go back to my pod. I will show you two ways you can do that. So from here, I will switch the mode of my pod. So for the moment, the pod was working on the discover, and now is going to I'm going to protect it to deny this data exfiltration. I do that again. So now you can see nothing happens because the traffic has been blocked by NeuVector. So I have to stop it here. And we will see the difference now in the security event. You can see that it's critical, and the action has been to deny that data exfiltration. I go back here. So you can see the link is in red. And when I click it, I also see my rules, my sensor that has been triggered. Just the action is allowed here because from the network point of view, the traffic is not restricted. We have restricted from the pod itself. That means it's the pod that restricts that traffic from going outside and reach the destination. So that was our first scenario. I will just switch back to Discover. So from here, I have also a lot of options on the map itself. Just to show you, going here, and I go back to Discover. Let's jump back to the presentation. So the second scenario is also the one that we can where NeuVector can help to detect some malicious activity into the Kubernetes cluster. It's called a man-in-the-middle flow. That's very well known in the traditional network computing, but it's also possible to see that attack into a Kubernetes cluster, and I will show you that in action directly. So the normal traffic for my application is to go to an external website. That's the standard way of operating. Now I can have a malicious actor that has gained some privilege into my Kubernetes cluster, is able to create a new namespace called Evil, is able to create a new pod, and is able to create a new service that is going to intercept the traffic directly through this pod. So that means that the pod, my app, doesn't communicate directly to the external website, but goes through this pod instead. So let's see how we can do that. So for this type of attack, it would be possible with the standard Kubernetes tools to see that, but you have to catch it at the moment it's happening, and you have to think about it to run the proper command. So NeuVector automatically catch that type of attack without any configuration. So I will show you. So that's the standard way when my application is working properly. It goes to the external web server outside of my cluster. Now I'm going to deploy my my man-in-the-middle attack. Is deployed. So now when I again try to run some traffic, I see I'm not going to the external web server anymore, but instead I'm going to the evil pod. So let's see how NeuVector can see that. You can see there is a new event that's called external IP man in the middle. So automatically, NeuVector is able to capture that event and identify there is a man in the middle attack in my cluster. If I go back to my network activity, so first you see that my app doesn't go to the external, but there is a link to this service that is not the normal behavior of my application. And if I click on the link, I also see here directly the man in the middle attack. And here, if you want to protect from that attack, I will show you from here how you can protect it. So from here, you can review the rules. You see that there is a connection from this pod to this service. I'm going to deny it, and I'm going to deploy this rule. And automatically, in my policy here, in the network rules, I have a new rules with a low ID. That means it's the first rule that is applied that's going to deny that traffic. So now, if I come back here again and I try trigger my attack. Yes, so it's still working at this stage because my rule is in place, but there is a last thing I have to do. I have to protect my pod to put it in a protect mode in order to avoid this attack from happening. So here, I'm going to protect it. Again, you can see the color change here. My pod is in the protection mode. And now if I'm trying to run my attack, nothing happens because the pod has been isolated. No traffic is going out of that pod. And almost on time, so I will just show you a last example. I put it back to discover. I'm going to delete that man in the middle. So it could be a stealthy attack that could happen just a few minutes just to capture some traffic from my pod. If I delete it again and I run my traffic, my standard traffic, I see now that the traffic is going back to the external website. And so I'm not aware at this stage that something happened on my cluster if I didn't apply the command to check it with the standard Kubernetes tools. So that's it from my part, and now we have time for some questions. If you have some questions about Rancher, autoscaler, or NeuVector. So you have seen this is it could appear like some magic tricks because you need some tools to make some nodes appears or disappears, or to have some visibility, some observability into the Kubernetes cluster. And so now, if you have some question, we are ready for you to respond to your question.